Hello everyone, welcome to our second video on the rules of exponents. So this is from section 4.1 in the book. So first rule we're going to talk about today is the power of a product rule. All right, so first of all, if a and b are real numbers, right, and n is any positive integer, then if we have the product of a and b to the nth power, then that equals a to the n times b to the n. Okay, so in other words, the way that I think of this, and you can um, think of this however you'd like as well, but the way I think of this, kind of like the distributive property, right? First of all, remember that anything to the first power is itself, right? And that goes both ways. So if I have a by itself, that means a to the first power, right? And b by itself is b to the first power. And so what I'm doing with this exponent here is I'm basically distributing it. I'm distributing the n to each of those exponents, right? So 1 times n is n, right? And then 1 times n here is also n. Okay, so I'm basically just distributing that exponent on the outside here and multiplying those times the exponent on the inside, right? And notice how the bases stay the same, right? I don't change the bases, just the exponents, as with a lot of these exponent properties. So let's take a look at some examples. So this is from the book, number 46, section 4.1. I can't remember the page number actually off the top of my head, but I'm gonna do the same thing first, right? I'm gonna first think about, okay, this is w to the first power, right? So if I don't have an exponent, there's always a 1. So the reason I put that, or one of the reasons, is like this exponent here, the 2, only affects the y, not the w, right? Sometimes it gets misconstrued that that exponent goes with the goes with both letters, goes with the w as well. But remember that exponents only affect what they're directly touching. Okay. So now that I have that squared away, now I can distribute. So I'm going to multiply 6 by 1 and 6 by 2. So as I write my answer, my variables don't change. So I still have w, I still have y. I leave a little more space for the exponents here. Okay, and then 6 multiplied by 1 here is 6, and 6 by 2 is 12. So we get w to the 6th, y to the 12th. All right, and that's our answer. Okay, so number 48, let's try that one. Excuse me. All right, so first of all, I'm at least going to remember that, okay, well, this is negative 3 and to the first power, right? And I have r cubed. So now I want to multiply this outside exponent by the inside exponents. Okay, so I'm going to keep the same bases. I'm going to have negative 3, and then 1 times 3 is 3. Then I have r, 3 times 3 is 9, right? So I can simplify this more, right? I can't do anything with the variable expressions, but I can simplify this, right? Negative 3 cubed. So negative 3 multiplied by negative 3 multiplied by negative 3 would be negative 27, r to the 9th. Okay? And so that's our final answer there. All right, number 50. Some similar aspects here, but now we have an extra variable, right? But same idea, I'm going to think about, okay, well, I have this negative 3, and it's to the first power. So now I'm going to distribute the exponent on the outside, right, to each of these inside exponents. So when I start to write my answer, or at least the next step, I'm going to write all the bases that I had before, right? Negative 3, leave room for the exponent y, leave room for the exponent z. So now I'm just going to fill in these exponents as they're going to be the products, right, of the outside exponent with the inside exponent. So 3 times 1 is 3. 3 times 2 is 6. So it'll be y to the 6. And then 3 times 3 for the z is going to be 9. Okay. And now I just have to evaluate. So don't ever leave numbers with exponents, okay? So we always can simplify that. So, and notice how the directions do say simplify, right? So we want to make sure that we simplify -3 to the third power. And we did that in the last example, so we know it's -27. And we just bring over the y and the z, and that's our answer there. All right, and last but not least, number 52. So here we have quotient going on, right? But remember, when we're dealing with order of operations or PEMDAS, we know that the numerator and denominator are as if they're grouped together, right? So the numerator and the denominator, we want to simplify those first before we divide, okay? And so, so once again, you don't have to write this every time, but just remember that each number, each base has its own exponent, right? So 2 is 2 to the first, 4 is 4 to the first, a is a to the first. So we can multiply the outside exponent by all these inside exponents. Okay, so here we'll have 2. 1 times 6 is 6. Bring over the a, right? Multiply 2 by 6, we get 12. Then we have b is our base. 3 by 6 is 18. All right, we'll do the same thing on the bottom. So we'll take the outside exponent of the 3 there, and we'll multiply it by each of these inside exponents. So I'm just going to bring over the bases. We have the 4, the a, and the b, and fill in the exponents. 3 times 1 is 3, so that's the exponent of the 4. 3 times 1 is also 3. That's going to be the exponent for the a. 3 times 3 is 9. So that's the exponent for the b. All right, so almost done. Well, we're on our way at least, but we have some simplifying to do, right? We have 2 to the 6th, 4 to the 3rd, so I'll simplify those. So 2 to the 6th is 64. Can't simplify a to the 12th, can't simplify b to the 18th, at least not at the moment. 4 cubed is 64 as well. Okay, then can't simplify a cubed or b to the 9th yet. So now that we simplify the numerator, now we can use the quotient rule, right? And 64 divided by 64, these are not exponents, right? They're not exponential expressions. So we just do with them what we do with normal numbers. So 64 divided by 64 is 1, right? So those basically cancel each other out. And then with our variables, we have a to the 12th over a cubed, right? So I'm going to deal with those as kind of its own little situation here. So I'm going to, when I divide bases, what do we do with the exponents? That's right, we subtract. So it's going to be a to the 9th, right? Because 12 minus 3 is 9. And then with the b's, same thing, right? We're going to treat those as if they're isolated there. So b to the 18th over b to the 9th, we subtract those exponents. 18 minus 9 is also 9, right? So that's our final answer. Can't simplify anymore, right? Those are not like bases, so we can't use the product rule. And yeah, we have one base, one exponent. Can't do anything more with that.